Good morning. We're going to test some more stuff. We want to ensure that wall logs are being created. Technically, we only need the left side for this test. We want to open a wall log, create some data, cause truncation to happen. So we want wall logs to happen in two different places. Let's see, do we already test this in one of the other cases? Here, we check that wall logs have data. To do something similar, but not after shutdown. What does db init do? Yeah, that does insert some data. Good. Huh. I don't have a truncate. Let's add a truncate. Or checkpoint? I forget. Checkpointing. Here we go. This causes a checkpoint operation to run on the database. Which one is the default? I think I want something like this. Passive, full, restart, and truncate. All right. Which one? Let's go with an option to pass an enum. Or just an enum that has all five. That works. Default passive. Full restart. Kind on the checkpoint. Pragma value. Do we give a result? Duplicate definitions. Oh, how about that? Mine is better. Okay, we'll import the mode, and then we need a string. Actually, we just need a display. All right. Let's see. F dot right stir. Maybe we get rid of default. Let's get rid of default. Which one would we want? Good morning, Xenocron. How are you? Okay, what is the default here? Passive is the default. At this point, we will check that a wall log has been created. Then we do shutdown. Maybe we should have some more data. I don't know. I feel like we should test after everything's shut down as well. Just gonna grab this for funsies. We should have 2 of them at this point. And the second one at this point is probably going to be empty. Oh. One will be empty, the other won't. Okay, so this test will fail. Let's get it running. How are we today? Oh goodness. I'm pissed off at the cat. Cat woke me up early. Um I'm too tired to be truly pissed off though. Um Beyond that, where are we? Actually, I'm kind of glad to have a longer stream, so but a little tired. And let's see, what else? Where are we? So last night I adjusted some code. Where was it? See here or in? Yep. So I was able to adjust some code, but it required doing some unsafe casting of pointers to maybe on a init um, to initialize stuff. And I get random crashes now in certain places. So that we'll be chasing that down. Um, Not while it's running, only while it's shutting down, which is better than while it's running. Do unsafe stuff, get random crashes and rust. Kind of par for the course, right? And cleaned up the wall state. So wall state now has read write lock to wall shared state. And that has the shared state that we need to have across multiple threads. I did notice though that let's see if we run this, that it no longer crashes. That this will just run for let's say 60 seconds here, which is great. We can just hammer on it. And in debug mode, it's doing about 1800 mutations per second, writes per second. Too bad. So out of the box in debug mode with full logging, yeah, I just shut it down on purpose. Kill that. It does all right. But occasionally, if I just run, I've got 3 started up, Control C. Yeah, there we go. Perfect. Segmentation fault on shutdown. So I have to figure that out. However, I noticed that wall logs were not always being rotated at the right times. So I wanted to write a little test for that, which is where we are at the moment. So I wanted to ensure that when the file basically goes back to 0, goes back to the beginning of the wall log, that it gets rotated. So that's the purpose of this test. Okay, so what was our crash before? 125. Test context 125. Failed to fill whole buffer. Oh, fancy. Is this from the FIFO reader? Oh, okay. How much did you read? 0? Okay. Let's. It looks like it did that a whole bunch. Why? So it's just spinning on that because there's no data in the FIFO. I thought it would block. What does this mean? Does this mean that the other end isn't attached? Hey, Mustafa, how are you? I'm doing well, thank you. Uh, the tests. Why? Why is this not blocking? I thought it would block. It was blocking before. Right. I'm doing that. So I think it should. I think we have something else set up incorrectly. Probably due to my refactoring, which is why it's good to have these tests. Give you that confidence that you haven't butchered something. Okay. So I think I just want to inspect it starting up. Let's just zoom in. Okay, so it does open the mutation file. Fascinating. See, I thought that this was working before. I do not believe we changed this. And we could use db mutation read and use our FIFO here. But this requires a future, which we're not using at this point. This function's the wrong color. Fascinating. Okay. We're not getting the same issue when I just run. Are we? No, because that just churned through the data. However, we don't know. We don't actually know if data plane was getting data. So in this case, let's just make a small mutation. Okay, there's our mutation. And what happened? Sending, let's see, seasoning is changing. So we're opening up this database. We have some of my debugging. I need to remove that. Main DB gets opened. We look for a journal. Open a file. File name is testdb3-wal. Good, good. Main DB bits. Check the file size. Some more checks. We open the DB again. And okay, this is multi-threaded. Okay, our wall log. Great. Skipping the main DB bits. Then we have wall. We see that the seasoning is changing. Why is it changing? It's being set because we're writing the header. Okay. We write a page. We notify data plane that there's data. Notifying change. This is on the VFS side. Does this look right? Salt 6748. Yes. Okay. Start and length. That's correct. Okay. Then data plane receives this information. 6748. Good. It then has to go and search for the data. Wow. It is told about this before the wall right returns. That's amazing. Look at that. Like, we commit to disk this data and then send some data over the pipe. Okay, it's blocking. I get that. But we're indexing some files. This one has the salt pair. I don't know why it does this twice. That's interesting. Get wall log. 1, 2. Oh, indexing file path, vacant entry path. Okay. Registering wall file into index. That's fine. Oh, okay. Looks like I had some trash from before. Find it. It's in that file. Okay. And it's the first change. Great. 6748. Good. Okay, so data is being sent over. I don't want to fight it, so I think maybe in a thread we set up Tokyo just to use that other code so we can do exactly what data plane is doing. We don't need that. Don't need that, that, or that. This goes away. Get rid of the outer bits. And, okay. Open it. No. Break the FIFO. Open the FIFO. What do we do in data plane? Is there a special Tokyo? There is a special file for this from Tokyo. So while we can create it, we should not open it unless we're inside of Tokyo. Okay. Gauntlet, cargo, Tokyo. Pull that in. Tokyo, run. Run time. Where's our runtime builder? Runtime builder. There it is. So we could do a builder new current thread. Okay. New current thread dot enabled all. Sure. All right, runtime is result. Let's unwrap that. Okay, there we go. Now we have a runtime. Runs a future to completion. This is what we want. What does this return? Ah, the output. Okay, that's fine. And that's a DB mutation. Lovely. And we were sending the buffer. Now at this point, we could just send the DB mutation. So let's do that. Okay. This goes away. Oh, we need to send. Lovely. Or if let. No. Okay. So we have our shutdown. Good. We just broke a couple things. So let's go fix those. We no longer have a FIFO shutdown. We have a data receiver. But the type is now incorrect. Shutdown goes away. Let's remove that. Here. It's a receiver of DB mutation. Hmm. I don't think that's correct. Oh, it is, because we're not doing anything with the data yet. TX, RX, return the receiver. We send the sender into this. Okay. If it's a channel, there's no limit to the size. Okay. Angry Maid, thank you for that follow. And Whiskered Cat, thank you for the follow. Okay, let's try our test to see if that keeps that from crashing. Okay. Good. I think this is a better location. Yep. All right. So this should be one. Why is it not one? We should have had a database mutation. Oh, where's our log? No logs? We're set to trace. Hmm, yeah, that's fascinating. We're not getting tracing. I wonder why. And this panic, though, I think this is expected. This is because the other end died. Just double check. Yes. Okay, we'll leave that there for now. So, why are we getting nothing back? Gauntlet, arena. Hmm. It's hiding certain files. We have no left logs. What? No, 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 no. Is the VFS not getting set up? I guess that would make sense. Almost. Because when we run just run, we see logging from it. So it must have been hooked in. Did I load VFS here? We open using with VFS. Yeah. And if that failed, we would know. Hmm. What is he logging? Let's get the logging working. Go build and cargo test. No capture. Fascinating. Okay. So that could either be due to the fact that logging didn't, like, it just didn't no to startup. Why would it not no to startup? Maybe the VFS didn't load. VFS lib. So here we initialize the settings, load settings. Let's see if that shouts loudly. Oops, borrow, of course. Log spec is off. Oh, well, that'll do it. Let's trace and off. So trace here, standard out will only. So it's presumed that logging logs more than standard out does. And so if you're logging your file level has less data than your standard out level, you can't, like, you're filtered by the file level. Okay. Well, that's the problem. Why is that set to off? I thought we just saw that. So we're passing trace in, log level. Here, prepare the directory, log level, write test config, and it's set to off. Okay, fascinating. How did that ever work? Nightshade dude, how you doing? Now we should get tracing. Nothing? Oh, don't do this to me. Oh, wait, did I do a build? Cargo build, yeah? VFS lib. Let's debug the settings again. Oh, well, there's your problem. Because I forgot to format it. How about now? There we go. Okay. Lovely. Get rid of that. So the issue that we're having is this error here is caused because there was not a wall log rotation at any point. We insert a bunch of data. This is when we start writing, because we can see seasoning is changing. There is nothing currently there. Notify change a bunch of times. And an error. We have not gone back to the beginning. So maybe it's not an issue. What's going on here? Maybe be wall sync. That's interesting. We sync twice after writing. Once, twice. 4840. The same file. Hmm. Okay. Then we start reading. Reading from the wall log. We close and rotate. Okay. So the test is correct in that we're not getting a wall log generated. SQLite actually, it's not attempting to reuse the wall log. So we're not actually triggering a situation where we would need a salted wall log. Let's go back to our tests here. I think that passive isn't going to do it. Let's go with a restart. Early in a file. Okay. We received some other error. Left. Okay. Panic dead assertion. It looks like we added some data to the database. And oh, I wonder if the problem isn't that we've told it to truncate, but that we didn't write any data after we told it to truncate. Or restart. Okay, let's set that back. Left.db. I don't know. Insert, update. Update. We have to give it a row ID. Insert just adds data. So at this point, we should try to do a database mutation because maybe its internal state was set to go back to the beginning of the file, but it just didn't write yet. Head hurts a bit. Yes. $119. Okay. Let's see what happened. I want to know when these messages are being acted on. Let's add a little bit to the bin here. We had been debugging. Received message. There we go. Now we'll see it. DB insert. All right. See, we didn't actually. So we got checkpoint. It does something to the main database. Not sure what. And DB insert. Doing some shared memory bits. Then we do a write. I wonder if it's not checkpointing because there are too many threads. Too many, there, but there aren't. We only opened left, didn't we? We didn't tell write to open a database, so it's not attached. Let's try full. New glasses. Yeah, that'll do it. That shouldn't take more than a week or so to adjust to. Hmm. Okay, full didn't do it. Let's crank it up. Restart. Again. Still no. Okay. Truncate. Okay, this checkpoint truncate stuff does nothing. Unless I have the pragma set up wrong or something. Here in about a week. Yeah. Well, if it goes on for 2, maybe talk to your optometrist. Hmm. I thought this pragma would work. Wall checkpoint. Am I doing that right? No, look, I spelled it wrong. It's wall checkpoint. What does checkpoint do? Checkpoint full F sync. What's this? Ah, okay. All right, now we probably have this set too stringent. Kate, read, read. Okay, it's reading. Well, truncate. File says 0. Okay. I don't think we actually want to call that. Renaming. Good. Technically looks like it worked. Yeah, I don't really support this method at the moment because there's, well, for reasons. This is in this section. Yes. So Maybe we should add it. What is SQLite expecting at this point, right? See, I'm not sure what size means here. Why do you truncate a file to a size for a wall log? And when it starts to pull data from the wall log, it does that from the beginning, I thought, because of other readers. As if you can truncate data at the end, then you can also truncate the data at the beginning. So why would it truncate for something that's a non-zero size here? We did get a truncate of size 0, but that's not guaranteed. All right. Truncate. Oh, nothing. Documentation. X. Truncate. X truncate method truncates a file to be n bytes in length. Okay. If the file is already n bytes or less, it's a no op. Okay. Hmm. This is for an application defined page cache. Okay. That doesn't really help. It doesn't say why. It's explaining what's happening, but not why it's happening, which arguably is more important in documentation, which they normally do a really good job with. Okay, let's also check the forums. Legacy. Request for extension of SQLite VFS struct. Why? Oh, okay. Something else. All right. Well, I say we return an error if we cannot be truncated. Match size. Or if size is 0. If 0 is equal to size. Sorry, C programmer is showing. So, once upon a time, I worked a lot in C and C++ and different compilers and all sorts of stuff. And you learn very quickly not to have your variable on the left-hand side because if size is equal to 0, do this, right? do some magic code here. Well, what's going to happen? You're going to assign 0 to that, and then this will never happen. Or worse, if you assign 1 or something else to it, then it always happens. So, assignment operator would be rather triggering. But most modern languages will complain about that in a if condition. Yep, set to always true false. You've definitely done that. Yeah, I've actually lost a week on that before. Never again. All right. So if it's 0, we do something. Otherwise, let's not return. sqlite 3. Huh. What was it called? Let's go to this one. IO error. Oh, look at that. IO error truncate. Fascinating. Why not? Although we should probably see if that means something special. Oh, perfect. Okay. I'm glad we looked. See, we don't actually ever want to truncate. I think we should probably just rotate the wall log at this point. If somebody's saying go to 0, why not just do that? We would basically go back to the state of the very beginning of a program where there was no wall log. And that's okay. Let's try that. How do we want to do that, though? I think what we're looking to do. So normally we want to write the file header, right? And as part of writing the file header, we might rotate the wall log and then open a file again. Which we could do. However, we would not know the new salts. What do we do with the new salt? We have old salt. We set some salt. So basically we need to do this, but with a take salt, because we won't know what the new salts are. I'm just going to grab this and go back down to truncate. That's Arguably, we should extract this out to something more useful. Nope, nope, almost. Take salt. Yes, there we go. So we close the underlying file. What if we can't do it? Let's extract this out. Rotate wall. We'll give it a couple salts and a file. Is that view 32? Salt 2. Scient. Okay. File also has a return that we're ignoring. Not sure what to do without flags though. Okay. Mismatch types. Let's uh there we go. Okay. Now let's get that other function to use this as well. Salt 1, old salt 2. So now we truncate, rotating the file. If it's a size of 0, otherwise we just don't support it. Lovely. 161. Hmm. Execute. Wait, what happened? Truncate, we rename. Here's truncate. Don't don't we normally get an insert after that? What else? What else? What else? So we start the file, add a bunch of data to it, ask it to checkpoint. We pull data back into the main DB. You can see there's a bunch of writes. Then we truncate to size of 0. So we rename that to that. Now, is this number correct? Let's check our salt. 2794. Yes. Okay. That looks good. We didn't even get to inserting the next bit of data. Why? So that supposedly finishes, and then this does not. We're supposed to get a row ID back. Interesting. But it's almost as though we didn't even see that message come through. Like shouldn't there have been a debug somewhere? E print line like this received message for insert, and that just never happened. Is it because it was shutting down due to an error? Hey Nathan. No, it would be too slow. We use a fan out method. Um, Good question though. Let me show you the architecture. So here, it's basically what we're doing. We host the applications on a mutation machine and then a bunch of read machines. The proxy recognizes the type of request, sends the reads to the um, you know battery of read machines, and if it's using mutation, it sends it to the mutation machine where we observe the mutations that are happening, and then as they are happening, pick them up, send them off to a what we call a data plane, right? Our data archive sees the change and fans it out to all the readers. So now, what you're asking about here, yeah, we would have been using um, something similar to Raft here without putting the data into the Raft log, because that just would have been a ton of data to put into a Raft log. And now, we're favoring performance over um, having rock solid kind of synchronization globally. Could you imagine if you had to block the write of a database until the database was synchronized globally? That would kill it. Okay. Good question. Good question. Okay, what does this error message mean? Execute returned results. What? Where do we even have that? Is that a SQLite thing? Were we supposed to get the results, but we didn't? Hmm. What happens when you can't fan out to all the reads? Well, they pick up from the data archive when they can reestablish a connection to it. So the data really just needs to get to data archive. If there is a partition split, something like that, sure, reads can still happen, right? But mutations would have to go to the mutation machine. And if due to some sort of partition split you couldn't reach the mutation machine, then mutations just wouldn't happen. Yeah. So let's say some transatlantic cable was cut and people in the EU were not able to reach some sort of machine in Virginia on the east coast of the US. And yeah, then maybe a forum post just wouldn't happen. But you could still read the forum. It would just look like it's not updating. And we would probably respond to the users saying, hey, can't post right now. Oh, looks like my screen just turned to light mode. There we go. Back to dark mode. Okay, well, I am a little perplexed as to what's going on here. So checkpoint, we get to gauntlet. We checkpoint here. Should we be getting the result of this checkpoint? I think we do this in some other plays. Maybe checksum, yes, here. So in this case, we query row. You know what? I'm going to convert it to something like this. Oh, that's right. Okay. This is our test code that we're going to drag this into. I think we'll be all right. Hmm. This almost feels like it should be shared somewhere. That feels like it's a SQLite tool or shared code. All right. Well, let's get this. Okay. I am kind of curious what, let's see, okay or busy. We want it to be okay. And it looks like we figured out what this meant, though. Okay or busy needs to be 0. Oh, that's right. And it loops until it gets it done. That's right. Moved pages, wall pages. So we want those to be equal. Basically, we want this. Okay. Just gonna let the tester figure it out. Okay, or busy. Mismatch types. Expect unit type. That looks like a unit type. It's complaining about that. At the bottom, format. That should work. It's an error. Ooh, else. Let's grab this. There we go. All right. Now let's see. Are we getting an error here or something odd? We had a file. Okay. Seasoning is changing. Yes. Okay. So it was important to read the result of that. So we did our truncate. We rename, we do a db insert, and then it looks like the very beginning where we're seasoning the file again. Lovely. Then we close, and at this point, everything shut down. As here, left was 0, right was 2. Ah, yes. We called cleanup too early. We deleted everything. Again. Nice. At 183. Now, in this case, we have 2 elements. So we have 2 items, and they both have data not equal. So the first one and the second one. Nice. Okay. So truncate works. That's a good change. Insert many. Goodness, that's a little bit of a dumpster fire. Um, 'Cause here we're just trying to crash it basically, and we were doing some benchmarking, so that this technically isn't a great test. Okay, I gotta pour some more tea. Well, that's good. Now, if we clean up dev1 appdbs, just remove all of that. 6 files, sure. Logs. Yep. And we run. Okay. Everything's there. We're going to hammer on that for 10 seconds. So our system's running. Lots of logging going on. Great. Okay. Everything's just sitting there waiting. Nice. We hit about 1,700 requests per second. Okay. Not bad. Could be better. Now, I want to check and see. Let's open a new tab. CD dev1 logs. No, let's go to appdbs. See, we don't have a wall log yet. We just dumped a whole bunch of data into the database. Did it just never season yet? It's possible, right? Now, SQLite might, here in a little bit, decide that it's going to checkpoint when everything's nice and slow. Where were we here? Lots of logs. Nothing was seasoned. Yeah, seasoning is changing. I don't think RG is case sensitive. Oh, no, it is. Wait, if the seasoning is changing, we should have had some wall logs. Yeah, look at these salts. These salts keep changing. Okay, so we have a bug somewhere. So what is the first log? No, we were not able to capture it. But the most recent one looks like it was 119. Yeah, let's open 119. We're writing it at 0. renaming. Oh, so it did rename. Wait, are we deleting these files when we're done with them? Did I add that to data plane? Data plane. Was it DB changes? Remove wall log. What's this? There was an older version. It's been renamed. Clean up. See, this doesn't actually remove them off of disk. Here, old wall path. Wow, is that actually happening? Sorry, I'm just surprised that everything's going well. And okay. Um, remove the rotated wall log as we're looking for data in the new wall log. Yeah. I automatically clean up old wall logs already. Yesterday, I thought it was an error that we were not seeing those elements, but we are seasoning. The writes are going to 0. And goodness, we can just hammer that website. I wonder, or just file, cargo build, raise, cargo build, sample notes, and this just runs. Okay. Let's see if there's any perf improvement in release mode. Oh, and we should tone down the logging. Well, let's just do info. Okay. Build is almost done. Come on, linker. You can do it. I wonder which linker I'm using. Am I using the gold linker? Right now now the little example project. Good. And I'd be over the moon if this was like 10,000. If I could do 10,000 requests per second. Linker, come on. Come on. One more. So it's starting up. Hmm. App 1? Why is that? App 1 should have. Oh, okay. Uh, yeah, let's see how that goes. Let's hammer on it. I just don't want that. Okay. Let's kill it. Console level. Oh, run it again. Okay. Well, let's remove that. AO. Oops. Too far. One more time. All right. So we'll get kind of a little bit of a baseline, see how the app's doing. Last time we did this, we were surprised and found an error. Hmm. Fancy. Why is the AO still there? Ah, see? Surprised again. Rock file. These should all be release mode now. Please? Yeah. Yeah. It's still spewing data. Well, it'll go for 10 seconds anyways. 18,000 or 1,800. This is a debug element. Fascinating. And that's for app 1. App 1 uses notes 1. Notes 1. Warn and info. Oh, reverb.toml as well. Here. Okay, too many configs. And AO is still. Oh, that's gone. Why is that not? Proc file for data plane should be released. This is saved. Bizarre. Something's not right. Hmm. I'm not seeing it. What could it be? Bizarre. Okay. It was data plane still doing that, right? Oh, it's app one in VFS. Oh, okay, that makes sense. Okay, no deleting that. It's because data. No. Yeah, I'm gonna have to undo all this later. Um, notes.toml. How does it know which VFS to load? Here. Okay. So in theory, we'll have the right data, the right info, the right binaries, and we can run our test again. That'll be nice. And I woke up early today. Cat was in a mood. Okay. That looks more reasonable. Okay. Let's hammer it. 10 seconds. Data plan still spewing data. We should probably get that to 4,000. Oh, look at that. We doubled. What's this? Is this? Oh, those are just debug lines. Four one four. Okay, that's the line. One more time. I want to see if we'll double again. Having anything in your process that writes to standard out just slows your application down so much. That linker. I really appreciate all the effort it goes in that goes in to something like that. I think this is one of the reasons why Rust could not have been made 20 years ago. You just didn't have the CPU horsepower or the memory. disks that were fast enough. All right, here we go. Okay. 5,000. Man, that's so much better. And if we nerf this, do we need to do that at all? Um, let's make it info. Debug it is. This is a commit page. What? Okay, fine. It's commit page. 6,000. Yeah, and if each time we remove just one log line, 165 and 210. Let's leave that one. Basically, what I would love is if this was like 2 orders of magnitude faster than like LightFS. That'd be amazing. If I could handle that many more changes per second. And I know that this benchmark is really cheesy and not very great. And it's not running on some sort of web server, right? It's running on my MacBook. 8,000. Okay, it's almost there. Well, that's pretty cool. I suspect that this line here slows it down quite a bit. No, not that one. Isn't this one? Notify commit end. Here. This does. So if we comment this out just for funsies, real quick. So this is the communication channel between our VFS, the SQLite plugin, and what's receiving the data in order to send it along. We call that data plane. Lots of stuff going on. 9,000. Okay. Yeah. One more time now that the cache is hot, all that. And we're just inserting into a database. Yeah. So waiting on that FIFO is slow, but not super slow. Oh, we could probably optimize it though. Not today. Not today. It's just good info. Okay. And set that back to debug. Change some of our TOML files back. What else do we change? Data plane? There we go. Just file. That goes back. Rock file. That goes back. Okay. Good. I want to just remove everything and release for a minute. Save a bunch of disk space. And make sure that we're not actually using anything over there. Good. And we're back down to just thousands of requests per second. Now, let's see. The last little bit I want to do before I get this committed is I introduced a bug with some of these changes. Let's see, will any of the tests catch it? It says on shutdown. No. Okay. So the way I've been able to reproduce this is just by running something like that, hitting Control C, killing it. I think I have to get further into the application. It's waiting for the FIFO. So let's just start the FIFO. Data plane. Okay, we'll just what? That should be there. Oh, we're in the wrong directory. Here. Okay. Data plane's running. And if we hit Control C occasionally like that, we will get a segmentation fault. All right. Control C sends what? SIGINT. Can we do this without? That was what? Notes that we're running? There we go. If we kill this, kill dash s int, does it die? Oh, it does. Okay. Can we see what's going on if we use LDB? Oh, it's already set up. Good. Okay, that's running. Okay, so we have LDB going. We kill that. Process stopped. Hmm. What's our backtrace on this? Parking lots. Yo, runtime bits. That doesn't look like it's crashing. Oh, wait, here. Or is this just registering like a panic handler? I think that's all it is. It's because here we're blocking, right? Runtime block on, blah, blah, blah. Okay, if we continue, process resumes. Hmm, that's different. Okay. So how do we get this to crash? We could programmatically shut down. So right now we're waiting for a control C. What if we just Tokyo 5 sleep from seconds, let's say 3. And just do that and then shut down. See if you crash. Theta 37, thank you for the follow. Let's run notes here. Give it 3 seconds. And does it crash? Not that time. Oh, it did. Okay. Ah, we might have something. You bad access. Oh, perfect. First try. Where? Tell us more. Reverb, VFS. Underlying file methods, P methods. Interesting. Platform I think I know where this is. Why would this be getting called on shutdown? Oh, wall close. Okay. So we're closing a file. We access P methods. Did something else get called? And we have sqlite here. Leave mutex and close zombie. Betray, pager close, wall close. Interesting. Well, this is great. We have a little bit of information to point us in the right direction. Looks like it's doing a mem move. Okay, let's look at the code. Closest we get is here. That's going to be VFS lib. 241. Huh. Address is 0. Really? Okay. This just might be an uninitialized file that was never set up. P-methods doesn't have to be something. But where was this getting called from? Line 8? What? Oh, okay. So somebody's calling underlying methods. Wall log 49. Wall close. Why would underlying close suddenly not be valid? Because P methods was not available, but SQLite shouldn't be mucking with the memory until all of this is closed up. Maybe there's a little hint just before. What's going on here? So we're closing file 380, 630. Okay, this one's different. Closing two different files. How many did we open? Not very much data here. So it looks like we do an X open multiple times. One's for testdb3, one's for what looks like the wall log. So the main file, the wall log, the main file again, and the wall file again. Oh, I get it. This is because this is now done by multiple threads. So, okay. When everything goes well, we end up freeing some memory, right? We rotate the wall. So one thread, okay, we basically have two threads. They both have connections, but they have some shared data. They have both have connections to the databases, which is why you see them both open the main file and they both open the wall logs. And the problem with them both opening the wall logs is that there's now some shared state between threads with the wall logs. And cleanup, I didn't clean up. So here, when we do the underlying close, that nulls out the memory for the data on P methods, doesn't it? Ah, but that shouldn't matter though, because each wall log file gets its own file. They share the same state, not the same file. Oh, is underlying part of the, oh, it is part of the, okay. Nope, I was wrong. They do share the same underlying file. I don't know if SQLite would be happy about that or not. I'm gonna think about that while I pour some tea. I don't think it's going to cause an issue other than us misusing it. Because before each thread, so they end up getting the same underlying file based on the file name that they're trying to open. And that's important. Let's could make them aware of it and have some other sort of lookup for, let's say, the salt, but I don't like that. Okay, I'm going to leave it as is, but the threads shutting down need to be more careful. Maybe have a is closed flag or null this out. Does it only happen when we close? I think so. Why didn't this always happen? Ah, because both threads are doing it at exactly the same time. And sqlite gets to the point occasionally where one thread is ahead of the other and nulls it out, nulls the memory out before the other can read it. Otherwise, in the case where it's not crashing, they're so far in sync that they both make it into this call and grab the memory before it can be freed or nulled out. Okay. I think I get that. Underline close. And what object are we on? SQLite 3 file. Here we're getting P methods. Okay, this one probably can't do that. We're doing self.p methods. What is p methods? Oh, X close. Okay. We'll carry it. Give me a break, Rust. Come on. So here with p methods, we want to know whether or not the return's null. And that would be if we were just addressing this error here. I don't really like that as much. Because in this case, this is for any one of these files. A SQLite 3 file. This could be the main DB, it could be anything. Okay, well, if pmethods is null, so that returns SQLite IO methods. And here we do some dereferencing. So we get the underlying file. Let's check the stack again. Yeah, okay. So it's the dereference here in pmethods. That's really the issue. This one. All right, well, let's grab this. So we get the underlying file. Whoa, I just hit tab. Not sure what that did. Pmethods is equal to some unsafe block. This would be dereferencing self pmethods. Okay. Now, if pmethods dot is null, we'll know that we're already closed. Oh, but we don't want to close this thing twice. We need to know that this thing already closed. So we need some other trait value, or trait function. And at the moment, we're just tossing that on this, which we can't modify. Okay, so we can't do this here. We have to bubble this up. So whoever's calling that, oops, right there. And luckily for us, the answer is over here, which is wall close. So we need to track whether or not the wall log was closed and just not call close. Okay. And what are we? This is, so we need to get the state first. What's in there? Just making sure we're not going to cause some other mine to get hit. If all state is closed. How? Because we're doing some threading, we need to basically set that value, kind of a close. Wait, what does close file do on wall state? What? Huh. Underlying file. Who calls this other than that line we just added? Nobody? Really? get rid of that. No, 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 no. That is called. I know that's called somewhere. Um, because it was mutably borrowed. Yes, I get it. Why isn't this just a reference? Why wouldn't that be like that? I don't need to consume cell phone minutes. I mean, arguably it should be mutable, like a mutable borrow. Um, yeah, leave that commented out. Can't borrow as mutable more than once. No. Um, okay. Well, what we can do is a very short mutable borrow here to know whether or not we're closing the file, and then go through and do this later. I'm going to make fewer changes, undo that. Yeah, all state will also need to be down here. Close file. If we cannot close the file, return sqlite OK. This is wall state. It is close file. Fine. I don't want to reuse the name yet. Um, Basically, we want some sort of guard so that only one can close the file at a time. Or some atomic that says, hey, this is being closed, this is closed, it's done closing. Set. This doesn't. We need some Boolean. Cool. Let's see. How about we don't call it file closed? Maybe is open. Swap value. False. Order. Oh, that's the wrong kind of ordering. There we go. So in this case, we return the previous value. So file closing returns true if the file can be closed because the file is open. We set it to false. Okay, that should work. Okay. So now we should see this getting hit and the exceptions not happening. Let's give it a build. Oh, that's the VFS cargo build. Sample nodes. Okay. I'm not seeing the log line. Let's crank this up a little. Make it a little more obvious. Like it's not happening anymore. That could just be due to the fact that we now have the atomic there. And accessing the atomics causes the threads to synchronize. Well, the good news is that there's no error. Well, I'm glad we looked into that. Oh, wait, it did it. It crashed. No. Really? Uh, why would you crash? I think we could also change it a little bit. Let's hold on. Let's sleeping for 3 seconds is too long. We could just do one. That's the wrong one. We're gonna build. And it did it. Lovely. Underline close still. But okay, we must have some sort of logic error. Yep. So we get this state. Set file closing is open. We swap values. We set it to false. So the first thread sets it to false. It gets back true because that's what swap does. It returns the previous value. So then the second thread comes through. It gets the state. Says, hey, set this to false. Sets it to false. Gets false back. If we cannot do this, we return. Okay, I'm not understanding this. Should I want to see? Can I do that? Yes. Okay. Why would this never have been initialized? So we're protecting against this thing closing twice, right? And in this case, we should have already seen, hey, this is closing. Or it never got set up in the first place, which is really bizarre because why? Unless it just never gets set up. I guess that might be possible. Okay, we set up the database. Now, specifically, this code is for wall logs. So we'll pay attention to wall logs. Say X open here. Fine. we don't know if xopen actually set it to something. I presume it sets it to something. It asks for a file size, in which case it must have worked. We have multiple threads here, though. Okay, let's see which thread. Closing this. C0F0. Okay, which one was C0F0? Not this one. Nope. Oh, wait, I was looking at the wrong thing. Should have been looking at the file. Okay, this one. So basically, we're looking here. C0F0. Do we do anything with it? Or do we just call shutdown on it? We just wall close. It's on the other one. Wall close on this one. It might never have been initialized because SQLite just opens it and then later closes it. But I thought that in xopen, see, one of the requirements. Hey, sarcastic Dante, how are you? One of the requirements here is that p methods is set here. So we initialize a file with nothing there, and then where is it? Here. If p methods is set by the xopen call, set up our overrides. So in this case, we would have set up our overrides because p methods would not have been null. And so it must have been there. These are getting used all the time. Read, write. What was it that? I guess we only saw close and open for this file. C0F0, we open, and then nothing ever happens to it. Oh, hold on. No, that's not quite right. I have a bug here. So we get the wall states. Okay, we get the shared wall state for a given underlying file. So we initialize this. So we have state already. Why isn't this used? Where is this used? It's not used there. Oh, it's here. So we set up this with, but we expect the p methods to be correct. But the underlying file's already been set up. because that's in state. We don't actually have to call this. Go away. Let me think that through. Ooh. We need to call this. Initialize the underlying SQLite file, giving it memory located after reverb. But we've already done that. See, we're just not going to use the same underlying file. We only use that in one case. Here in state, this points to a shared underlying file. So methods is null. I think this here is incorrect. So what would this do? This would set up a brand new underlying file. For what benefit? No benefit. I think this should probably be moved up in here. Because we only want to do that once. I'm going to stage some things. This can reset that. Data plane. There, we'll just do this quickly. In this case here, we want to initialize the underlying file. And we're initializing the underlying file here. Where is default VFS used? Okay, nothing. Those two things can get moved here. And what are we doing? Default VFS, we have that already. Right? Reverb was set already. Yes, here. Okay. So now we don't initialize an underlying file when one isn't needed, because we'll use the same one. That's handy, but result doesn't exist anymore. Yes. What if it fails? Boo. Or insert with. How do we fail? We could get an entry back and not use this pattern. Okay. You know what? Let's just do that now. State, shared state wall. So we want file name to state entry. Oh, Kira, how are you? This project is compatible with SQLite. We want C-string file name. Entry is equal to that. Okay. Let shared all state equals match entry. Fill match arms. Great. So if it's occupied and we have an entry, we will just return that entry. If it is vacant, we must fill it in. Okay, get rid of that. Take this, toss that in there, get rid of a little bit of extra code, and entry equals actually that. Incompatible types in the match arms. So we set the entry and then we have to return a value. What type of value is this? Oh, that's an occupied entry. That's not what we want. For this entry, we want to clone that arc. Actually, that's what we're doing down below on line 145. Entry dot here. Okay. Now this return type is incorrect. So we store that and then basically we do the same thing. Oh, is this a different type of entry? That's a vacant entry. We call insert on it. Okay. So call insert and state is equal to that. Insert arc clone of state. And then we return state. Good. Get rid of that. Okay. Now we have our wall state. Good. This can go away. We do super unsafe stuff. Super unsafe just because I'm not sure exactly if it's right. Okay. So then at this point, underlying file, where is this from? Oh, and this is not correct anymore. Underlying file should be. Wait, do we even have to do this if it was already set? Okay. What are we doing? We allocate some memory for the proxy file. Where does proxy file live? Is that here? Yes. Okay, so proxy file still needs to be allocated in setup, but it needs to point to the underlying file, which is in file state. This needs to be maybe the same underlying file as the previous one, not this. Okay, so I'll have to fix that. And the p methods, yes. Underlying IO methods. We get the version, that's fine. Is this used? Oh, here. Huh. Oh, I see. Just a different set of methods. That's fine. And then we set our proxy file to our proxy file p methods. Fine. Okay. So this guy here. See, we're required to set p methods to null. We return early here. This could be an issue. We need to get to at least this point. So I think we need to not return here. They are required, just like we are, to set the p methods to null on that. So we could check to see if that's getting set to null. If this does return an error, let's see, where can we store that? We could just keep initializing. Oh, because p methods, we might get, yeah, we can't. Well, it's protected. But what if they didn't actually set it? It's like a trust but verify. If they say they failed, let's believe them. We're not going to do a post init. Okay, we'll just return early. Or, no. So at this point, we actually need reverb file dot state dot underlying file. If it's not null, okay. Where's this used now? Only in there. Could move it in. Hmm. Let's extract this out to a variable. Okay, now it's pointing to the new location and everything's happy. I don't know that we actually fixed it though. Like we corrected an error. I think we actually had an error because these were pointing to the wrong IO method. Oh, that's weird. Okay, I don't know what that would have done. Bad access. No, wrong button. One. 182. Hmm, that's weird. Yeah, that looks wrong. What? Or keep allocating? We actually have to have them use the same APIs. Our VFS acts as an abstraction, so we can share an underlying file and just keep it open until the last VFS closes. Underlying file. Sorry, I'm a little distracted. Um, Review this again. If it's a wall log, we find the state entry. If we have one already, we use it. If we do not have one, we set one up. Default. So we call xopen here. That initializes underlying file, which, you know, in future cases, they would just get the same one because we're going to store this behind, oops, read write lock. So we have underlying file. We can always just say this. Insert it and clone it. Okay. So it should be initialized at that point. What about here, though? Would it have been initialized for these? No, Halsey. It would not have been initialized for these. Ah, fascinating. Okay. Do I really want to do this 3 times? Extract it out to a function? Because really, we don't. The only time we don't want to do this is when it's occupied. Here, right? If it's occupied, that's a no-go. We don't want to do the initialization. Let's just extract this out into a function. State init result. We'll have to return that result. Init underlying file. Okay, what's that look like? Good job, Rust. Okay. Now for each of these, we have to do the same thing. We have to initialize before we pass that in. We initialize, we set it. And nice, it worked. Well, compiled anyways. Let's run the test real quick. Oops, I didn't mean to do that. Split right. Go build and the cargo test. Okay. All right. What about a just run? Oops, I forgot. Notes main. What that, not that. Run one of those at a time. Good. Hammer it. See terminal spew. Okay. Not bad. Well, that's working. Let's try shutting down a couple times. Let's run this again. And just our target. Run it, shut it down, run it, kill it, run it, kill it. Ooh, it died. Really? Come on. Uh, oh, and that's why we need this. Okay. Exit it cleanly. Hmm, here we go. Look at that. It's showing us exactly the line of code. It's like right there. That's nice. Why closing a wall? Oh, this is main DB close? Wait, are we looking at the wrong one? No, no, no. Let's look at the backtrace. Look at the backtrace. Live, option, underlying file methods. Weird. See, it's in SQLite 3 wall close. Okay. Wait, debug, format, debug. Are we trying to print something? Lib. That's at the top of the file. That's in the macro. Hmm. Well, it looks like we're missing some pieces here. SQLite calls close. SQLite 3 close. Option. Why debug? Okay, I don't know. Self unavailable, blah, blah, blah. Underlying close. So underlying close was called, and that was called via the wall stuff here. But in this case, going back to the wall log, wall close. I don't think we saw this ever. Did we only ever see? See, this would be for the shared state. So this one is for 5480. And 5480 is associated with main wall log. Okay. And the other one that's associated with the main wall log is 6090. Okay. So when we start to see closes, 6090 and the other one, this one and this one share the same data. I say wall close freeing, wall close returning 0. Then we come in the next time and it's panicking. They are not using the same thing. Why not? Set file closing. Hmm. So why would they not be using the same one? Can we get the instance of that wall state and log it? One. Good. Wall reference. Okay. Now we need to build the VFS, run nodes. Okay. Well, that's disappointing. Or is it? What is that a pointer of? Oh, it's a reference to the wall state. I actually care about this. I want to see the wall shared state. shared dot. That's that's not going to give us what we want. We want. No, we don't want that. We want to know what the address is of the data. So shared here. It's an arc to RW lock. We want to know what the address is of the RW lock. How do we get that? As the arc should have a different address, the RW lock should have the same address. Something as pointer. Huh. Okay. Let's just do that. Oh, wait. That's, yes. Okay. Again, which state is used? Oh, look at that. They are using the same state. FC5B0. Yep. Run it again. Let's see. Can we get it to crash? Why did only one shut down? Which state is used? It ended, but it only shut down one. Okay, so there is a behavioral difference. Fascinating. Here we go. Which state is used? C6F0, C6F0. So it is the same. So reverb file, state, we get the state. Why doesn't this work? Stores a value into the bool, returning the previous value. Previous value is true, new value is false. And if we look at the logging, these happen quite like some time has passed. So it's unlikely that there's some sort of synchronization issue. Let's build it. Am I building it? Yes, that should build it. LDB. Result is true there. Result true. Result true. The result is true. Twice. Wait, is that... Why would it be true twice? It's not on the shared state. Come on, Halsey. This should be... Where's shared state? Wall state. I put it on the wrong object. There. Now it's on the right object. Grab this, take that from there, put it here. Shared dot. Oh, goodness. Okay. Now we're going to issue with locals and stuff. No? Okay. We know they're the same. Get rid of that. Wow. Well, that's going to be it, really. It was a logic error. Cargo build. Okay. Results true. Fine. I'm looking for a true false. I see the last one be false. False. There it is. True, false, returning. Boom. Fixed it. All right. That means that I believe we've addressed all the bugs that we've found so far. Let's give it a test. Oh, yes. Close that. Change notes back. And it's working. Okay. Let's get this committed into Git. Git. And some of these have needed changes. That one. And this one. Okay. I'll take that too. That's less important. I'll take it. Data plane, sure, why not? Yep, okay. Too many changes. I need to get my changes smaller. Yeah, that looks okay. Yep, we extracted that. Updated close. Made truncate work. Some dead code that can be removed. Okay. This reverb VFS. Fix. Fixed bug. Now, what was this actual bug? It was ah, there's a little bit more in there, isn't there? Fixed initialization of underlying file. Okay, good. Ah, right on time. All right. We gotta run, gotta raid. Thank you all for hanging out. Till next time. Bye bye. All right. Raiding Christoph. Y'all take care. Bye bye.